So today our topic is virtual short. Okay, virtual short and virtual ground. Okay, so first we need to see why we need to use the virtual short or virtual ground, and then what is virtual short. Okay, and what is the difference between the virtual short and the virtual ground. First, we all know that if this voltage is V minus and this voltage is V plus, then we can write down output voltage V0 is equal to AOL is the open loop voltage gain, okay, multiplication by V plus minus V minus, okay. And if we do the KCL in this point, this is a point A. If we do the KCL at point A, then what we will get? We will get V minus divided by R1 plus V minus V0 divided by R2 is equal to 0. So from here we can get V minus is equal to V0 multiplied by R1 by R1 plus R2. Okay. If we put this value of V minus in this equation, then AOL multiplied by V plus minus V0 R1 by R1 plus R2. Okay, this is V0. If we solve this equation and take out the data value of V0, then V0 will be V0 plus AOL multiplied by V0 R1 by R1 plus R2 is equal to AOL multiplied by what is the value of V positive is VI, right? As V pi is the P positive. So into VI. Okay. So just take common V0, then we can write down A open loop into Vi divided by 1 plus AOL R1 by R1 plus R2. Okay. If we further simplify this one, if we just common AOL, then we can write down Vi divided by 1 by AOL plus R1 by R1 plus R2 is equal to V0. Okay, so this is what we get if we just do the KCL and use the output expression of Opamp. Okay, here I didn't consider any virtual short or virtual ground, right? Now just use AOL is equal to infinity, right? If we put AOL is infinity, then this term will be 0. Okay, so just go to the next page. We get this equation, right? So if we just put AOL is infinity, then we will get what? V0 is equal to Vi multiplied by R1 plus R2 divided by R1 is equal to Vi into 1 plus R2 by R1. Okay, this one we get if A0 is equal to tends to infinity. Okay, but in some examination you will get the value of AOL not infinity, maybe 10 to the power 4. Okay, and they give you R2 is equal to 10k and R1 is equal to 1k, and they told you to calculate the value of V0. Then what we need to do? We need to put the value here. V0 is equal to, here suppose Vi is equal to 1 volt. Then Vi is equal to 1 volt by 1 by 10 to the power 4, okay, plus here will be R1 is the 1k, that means 1 by 11. Okay, from here if we solve this equation, what we will get is equal to 10.98. Okay, so if we didn't consider the virtual short, and if the AOL value is 10 to the power 4, then we will get 10.98, right? But if we consider AOL is infinity, then what we will get? We will get is equal to 11 volt with the same data. That means it's not that much difference, right? So that's why we assume that AOL is equal to infinity. So what we will get if AOL is equal to infinity? So let's see. V0 is equal to AOL V plus minus V minus. Okay. So from here we can write down V plus minus V minus is equal to V0 by infinity. Okay. So from here we can write down V plus minus V minus is equal to 0. So from here V plus is equal to V minus. Okay. So we will get the voltage at this point and the voltage at this point is equal. Okay, that's why we call it virtual short. Okay, now you will say why virtual, right? For that one, we need to see the op-amp internal circuit. For the op-amp internal circuit, how it looks like? It looks like this type. This will be a dependent voltage source. Okay, plus minus. This will be the output voltage. Okay, and this will be AOL into Vx, where this is the Vx. Okay, so this is the positive terminal and this is the negative terminal. Okay, so this output voltage is equal to, we can write down AOL into Vx, or AOL V plus minus V minus, the same equation. Okay, now you can see this is the V plus, and in this point the voltage is V minus, right? Here you can see these 2 points, this point we call A and B. A point and B point is not short, right? This 2 point is open. Still we get that V plus is equal to V minus, right? So that means without short, we get the concept of short, right? With open circuit. That's why we call it as a virtually short. It's not the actual short, it's a virtual short. That's why we get V plus is equal to V minus. And from here, if we use this concept to calculate the output voltage, then what we can write down? If this is VI, then this will be also VI, right? Then from here, if we do the KCL at that point A, then we will get VI minus 0 divided by R1 plus Vi minus V0 divided by R2 is equal to 0. From here we can write down V0 is equal to V0 is equal to Vi into 1 plus R2 by R1 is the same. This equation is the same when we assume that AOL is infinity. Then also you can see the expression is same. Okay, so we can assume virtual short when op-amp open loop gain AOL is at least greater than 10 to the power 4. As if it's 10 to the power 4, then we get 10.98 without considering virtual short, and with considering virtual short is 11 volt. So it's very close. So it's no problem. But in some problem, they will give you, this will be, suppose it will be 10 or 100. Okay. So if we put the value of 100 in this equation, then what we will get? V0 is equal to 1 by 100 plus 1 by 11. So what will we get? Is equal to 9.90. Okay. So when the open loop gain is 100, then you get how much is 9.90. And if we consider it infinity, then how much is 11? Or if we consider virtual short, then is 11. So you can see with considering virtual short and without considering virtual short, the voltage is much varied. Like this one is 9.90 and this is 11. So the difference is much higher. So we cannot consider it, or we cannot say 9.9 is equal to 11, right? We cannot say this one. So when the open loop gain is small, at that time we cannot consider virtual short. At that time you need to calculate the V0, V output by this method. Okay. In some exam like gate, jam, you need to do the work like this. You need to do the output voltage calculation like this and calculate the value. As at that time, suppose they give you this question where AOL is 100, R2 10K, R1 1K, VI 1 volt, and they give you the option A is 9.9 volt, B 11 volt, C 10, and D is the 11.1. Then if you don't know this concept, you will write 11, but that will be wrong. You need to correct it and you need to be click on option A. Okay, so this is the concept of the virtual short. Okay, now what is virtual ground? Okay, so now I tell you what is virtual ground. In some problem, you will get, in some problem, here you can see here is the VI, right? So why the virtual short? This will also be I. But some problem you will get the circuit like this, where this will be VI, this is R1, this is R2, okay, this is minus and plus, and this is ground, okay, and this is output voltage. Here, V plus is equal to V minus, and you can see V plus is equal to 0 volt. Why? As we ground this value, we ground this terminal, right? So that means by the virtual short, we can write down V minus is also 0 volt, right? So V plus is equal to V minus is equal to 0 volt. So this one is we call is virtually ground. Okay, so virtual ground is nothing but just a case of virtual short. If in the virtual short circuit, if a value voltage V plus or V minus is equal to 0, then we will call virtual short as a virtual ground. Okay, but for this question, you cannot say by using virtual ground we can write down this point is equal to Vi. It's wrong. Okay, but here we can write down by virtual ground we can say V plus is equal to V minus is equal to 0. Okay, so this is the concept of virtual ground. Now I think you already understand the difference between the virtual ground and virtual short. Okay, and how we got virtual ground and virtual short when if this one is equal to infinity. Okay, and why we need virtual short? As we all know the op-amp open loop gain is much higher. So if open loop gain is much higher, then if we consider virtual short, then the calculation is much easier. It's just a two-line calculation. But without considering virtual short is a very lengthy process. It's a very lengthy process, right? That's why we need the virtual short. But in some question, in some exam like gate, jam, they will give you the value of open loop gain. At that time, you need to do like this, or you just remember this equation and put the value. That is also okay. Okay. So now I already told you that if AOL is not greater than 10 to the power minus 4, we cannot use virtual short, right? So that means there is some limitation of the virtual short. First limitation is the open loop voltage gain should be greater than 10 to the power 4. This is the first condition, okay? Only if is the 10 to the minus 4 greater than 10 to the minus 4, then only the virtual short will work, okay? The second one is if our op amp work in the active region, then only the virtual short will work, right? That means virtual short is useless for saturation region. Okay, that means if the op amp works in the saturation region, at that time we cannot use the virtual short. Why? The gain is not that much. Okay, maybe in my next video, maybe in my next video I will do some problem where you can see is V positive is not equal to V negative. Why? At that time that op amp will work in a saturation mode. Okay, so this is all about the virtual ground and the virtual short. Okay, so thank you.
Thank you for watching my video, and share this concept with your friend, and like and subscribe my YouTube channel. Thank you.